So now discussed about that thermal analysis of flat plate collectors. So normally the body is subjected to solar radiation of the intensity. So it is partially absorbed by the body and remaining is transmitted and reflected. As per the heat transfer coefficient, as per the heat transfer concept, the sum of the absorbed, that is sum of the absorbed and transmitted and reflected energy is equal to the unity, that is alpha plus tau plus rho equal to 1. So that's also alpha is that absorption coefficient, and tau is the transmission coefficient, and rho is the reflection coefficient. So the absorption part of energy is used to increasing the temperature of the body. So normally that the portion of energy is lost by the conduction and the convection and radiation. For the thermal equilibrium, energy losses are equal to the absorbed energy. So now we have assumed as the thermal analysis purpose, the conduction and convection losses are negligible. So now the absorbed energy due to the solar radiation can be written as that is alpha I, and similarly the energy losses due to the solar radiation is epsilon sigma t power 4. So epsilon is that emission of coefficient, and sigma is called as a Stephen Boltzmann constant, and T for that absolute temperature of the flat plate, absolute temperature of the flat plate collectors. So now that is a thermal equilibrium, we can written as that is alpha I equal to epsilon sigma t to the power 4. So that the equation can be rewritten or rearrangement like as to be alpha, and likewise to be written to be like this. So from this equation, it's clear ratio of the absorption coefficient, the clear ratio of the absorption coefficient of emission, absorption coefficient to the emission coefficient, absorption coefficient to the emission coefficient is more leads to higher equilibrium temperatures. However, the amount of energy collected depend upon this ratio. So the mainly it depends on mainly high value of absorption coefficient only. If the flat plate collectors is made by the material having a higher value of absorption coefficient is painted with black colors or black chromes likewise. So that is a emission. Further, that is a emission, the equation can be rewritten including the diffusion radiation. So likewise to be rewritten like this. So here that is a Hc is the convective heat transfer coefficient, and alpha is the observer coefficient of the diffusion radiation, and I is the intensity of the diffusion radiation, and T is the atmospheric radiation. So that is the equation is valid based on the perfect insulated to be considered as a conduction loss are negligible. So next we have discussed on that performance of the flat plate collectors. So the performance of the flat plate collectors is described by the energy balance equation. So it is indicated shown to be here. That is a, you know that already previously we have discussed on the energy balance equation. That is, you know that Qu equal to AC Qu. That's a AC means that is a UL means the overall heat transfer losses coefficient, and TF is nothing but that is a temperature of the fluid, and TA is nothing but that is a temperature atmospheric temperatures, and AC is the area of collectors. And now we have QA is rewritten as a QA equal to tau alpha IP. So that IP is the intensity of solar radiation, that is a tau plus alpha plus tau, that is a product of emissivity of transfer cover and absorptivity of the observer surface of the collectors. So the useful of the energy can be returned, that is a previous energy as that is a useful energy, that is a energy output of unit per unit time, that is a flat plate collector of the area is distance difference between that absorbed solar radiation, that is for QA. So that is thermal losses, it having some of the thermal losses, you have the thermal losses. So next one is that efficiency of the flat plate collectors. Efficiency of the flat plate collectors means that is a, so that is a thermal instant efficiency, instantaneous efficiency of the flat plate collectors is given by the equation, that is a efficiency equal to QU by AC into IP. You know that QU and AC is collectors and intensity radiation. Likewise, that is a overall thermal efficiency coefficient of the thermal efficiency of flat belt collectors is given by, that is a ratio to be rewritten likewise, that is a overall efficiency to be written like this. Next one is the collector efficiency factors. So what are the collector efficiency factors means? That is a flat belt collector efficiency is defined that the ratio of the actual rate of useful condition, useful heat collection to the rate of useful heat collection rate. So when the collector absorb the plate is called that fluid temperature TF. So now that is a collector factors, that is a efficiency factors is defined as the ratio of actual rate of useful collection to rate of use of heatful heat collection rate. So when the collector is observing that temperature, that is a TP plate temperatures, is placed at the fluid temperatures. So it can be written as likewise, that is a heat useful to be likewise, that is a efficiency factors, F equal to form of the efficiency factors. So next one is that outlet of fluid temperatures in a collectors to be written in this equation. So the outlet of fluid temperatures for the particular temperature, that is X to L, in the form of flat plate collectors used as obtained from the, this is the area. So that is you know that this area collectors, and CF is specific heat capacity of the fluid, and the L are nothing but this length rises in a flow direction. So length of the observer, you know that UC and mass of flow rate, and you know that already you know that is a heat losses, and mass of flow rate, that is a flow of energy. So that is the, you have fluid temperatures efficiency, collector of the efficiency of factor to be defined. So from this equation, next one is the heat removal factors. So what is the heat removal factor means? That is a flat plate collectors defined, that is a ratio of actual energy used gained to useful energy gained, that is a actual useful energy gain to useful energy entire flat plate collector as a fluid to the inlet temperatures, that is in expressed in the terms of using this equation. So that this equation can be rewritten by that useful of factors, that is FR and AC, and QA is a difference of uniform deflections, sorry, heat losses, and fluids and atmospheric temperature, that fluid temperatures, inlet fluid temperature, and atmospheric fluid temperatures, that is rewritten by the equation. You write as a form this equation. From this equation, that is the instantaneous thermal efficiency of the flat plate collector can be written as, that is inlet temperatures with the useful form of heat removal factors. So next one is that called as, that is a optimum inclination of the flat plate collector, we can written as, that is a beta optimum is nothing but that is a psi plus or minus 15 degree to be obtained that optimum temperatures, optimum inclination of the flat plate collectors. The variation of solar radiation with the inclination of surface for the latitude and the orientation and the time of the day and day of years, this may be vary. So now should be optimum inclination to be received the maximum radiation. On the basis of optimum inclination to be written as, that is a beta optimum, that's equal to psi plus or minus 15. So if the positive sign means that is a winter condition, if negative sign means the refer as a summer condition. So normally that is the performance of a tilted is a 0.9 times of the latitude of the location, 0.9 time of the latitude of the location. So that is the optimum inclination of flat plate collectors.